held today that the most reliable defender of a country is its army, not any treaties or alliances. For Japan, separated from 1.5 billion strong China by just the Sea of Japan, and with which it has historically had very difficult relations, the issue of having a combat-ready military is becoming more and more relevant every year. One of the ways to solve this problem is to create a super modern fighter to withstand the Chinese armada of more than 3,000 aircraft, most of which belong to the 4+ and 4++ generation, the J-10 and J-11B fighters, and there are already some 5th generation machines, the J-20. The ratio of Chinese to Japanese combat aircraft is simply appalling for the Japanese, 6-1. What does the land of the rising sun intend to counter this real threat? What kind of aircraft does Japan intend to build? Let's look into it. The main combat aircraft of the Japanese Armed Forces is the F-2 bomber fighter, which is a joint development of the Japanese company Mitsubishi Heavy Industries, MHI, and American Lockheed Martin. The F-2 is a heavily revised version of the F-16. The planes even have slightly different silhouettes. The Japanese are slightly larger than the Americans. Japan has a total of 97 F-2 fighters and about 200 even older F-15J fighters. Initially, Japan planned to replace the aging F-2 Generation 4+ aircraft with the American Predators, the 5th generation F-22. But it turned out that adding another 2 in the name of the aircraft model would not work. In 1997, the US Congress decided not to export the F-22 Raptor. Despite great interest from Japan, the technology used in this fighter, the first of its generation, was deemed too important. And then, the Predator has withdrawn from production altogether. Japan decided to develop its 5th generation fighter. This led to the birth of the experimental X-2 Shin. Despite a successful first flight in 2016, the project was deemed too expensive. Then Lockheed Martin offered the Japanese Defense Ministry a very extravagant solution: to combine the F-35 Lightning II and F-22 Raptor designs into one aircraft. The Japanese wisely declined this risky undertaking. Soberly assessing the situation, the Japanese, in our opinion, took an unexpected but the most correct decision: to abandon attempts to create a 5th generation fighter and immediately create an aircraft of the next, 6th generation. And for the period when this super modern aircraft will be created, to cover themselves from China and North Korea with American Lightning, the F-35 aircraft. So in 2018, Japan sent out a request to buy 63 Lockheed Martin F-35A and 42 F-35B short takeoff and landing fighters, simultaneously with the commissioning of 2 Izumo-type helicopter carriers. It was decided to modify these ships, the largest in the Japanese Navy, to accommodate the F-35B fighters. The Japanese government has allocated $48 billion for the development of a 6th generation fighter, which has already been named FX. At the same time, it is expected to produce 90 such aircraft. That is, the cost of one copy will be an astronomical $533 million, over $500 million for one plane. For that money, it's possible to buy 3 times as many F-35s, but the Japanese are going for such expenses, and they have good reasons for it. You need fewer pilots for 90 planes than for 270, and the Japanese armed forces are more strapped for manpower than money, and the figure of 270 scares them to more than $48 billion. Second, the money spent on FX will largely go to Japanese companies, and could turn Japan into a first-class military aerospace power that will no longer be dependent on American companies and export policies. And now about the Japanese fighter of the 6th generation. Mitsubishi Heavy Industries was naturally appointed as its leading developer. In all, more than 1,000 Japanese companies will participate in the project. It is assumed that the FX will be larger than the F-22. Therefore, it has already got the nickname Godzilla. The large size indicates that the Ministry of Defense wants the aircraft to have a very long range and a large payload. Compared to its predecessors, the FX will replace hydraulics with electric actuators. The reason for this decision is the complexity of the stealth fighter's cabin design. When designing stealth aircraft, the internal weapons compartment and air intakes have to be taken into account. However, problems arose with the installation of hydraulic system piping due to insufficient rigidity. The adoption of electric actuators eliminated the limitations, as they are connected only through electrical wiring. A reduction in the weight of the aircraft is also achieved. To reduce weight, several technologies and manufacturing methods will be implemented in the FX. In particular, abandoning the use of fasteners in favor of bonding composite materials. Aluminum alloys and carbon fiber reinforced polymer will be used to create a heat shield for the engine. The FX's predecessor, the F-2 fighter, used carbon fiber reinforced polymer only for the lower part of the wings. In the FX, the entire fuselage will be made of carbon fiber. To improve stealth aircraft detection, the FX will use an electronically scanned active grid radar. The aircraft will have a self-defense radio frequency system. It will instantly turn off its radio waves if necessary. If necessary, the radar will be able to operate in a microwave weapon mode, frying the electronics of approaching missiles. To increase stealth in addition to radio-absorbing materials, the FX will use stealth plasma antenna technology to deflect radio waves. The antenna works by creating a temporary plasma that can change its physical properties through electrical control. When activated, the antenna is also capable of transmitting and receiving messages. The FX will be powered by two XF9 engines, which have yet to be developed. The officially announced thrust levels are 11 and 16.5 tons with the afterburner. This is slightly less than the F119 engines on the F-22 Raptor. At the same time, the FX will be heavier than the American, so it is likely to be inferior in speed and maneuverability characteristics. The engines will be equipped with nozzles with a three-dimensional thrust vector, which allows the aircraft to achieve high maneuverability, not inferior to the Russian Su-57 and the same F-22. It is worth noting that in December 2021, the United Kingdom joined the development of an engine for a new Japanese fighter jet, which means that the resulting power unit may well be installed on new United Kingdom Air Force aircraft as well. According to the British Ministry of Defence, joint work on the project should begin in early 2022, after the country invested £30 million in the planning and digital design of the device. On top of that, the British government is going to invest at least another £200 million in the engine. This investment is expected to help create a fully functional demonstration prototype engine, which will be manufactured at the Rolls-Royce plant in Bristol. The project also utilizes production facilities at BAE Systems, Mitsubishi Heavy Industries, MHI, and Ishikawa-jima Harima Heavy Industries. No details of the expected performance of the product were reported, so it is unclear whether the Japanese FX will eventually be powered by the XF9 engine. At the moment, Japan has one completed aircraft, X2 Shinshin, which was to be used as a model to demonstrate some of the technology that was later to be used in the FX fighters. The experimental X2 was equipped with IHI XF5 turbofan units, and these were expected to be replaced by the XF9 in the future. But now that IHI has partnered with Rolls-Royce, it has become unclear what role the authentic Japanese design will play in the project. It may serve as a technological basis for the joint project, or maybe something fundamentally new will be created as a result. It is known reliably that despite this cooperation, Japan continues to work on its FX program, but if it has access to a more efficient suitable engine, it may be installed in the 6th generation fighters. Another possible result of this business interaction could be the emergence of a new type of munition, namely the integration of an advanced radio frequency guidance head, developed in Japan, into British MBDA air-to-air missiles. Such weapons may be included in the arsenal of the new fighter. To date, the FX is expected to be armed with 6 ASM-3 anti-ship missiles, which will be placed inside the fuselage. The ASM-3 reaches speeds of over 3 Mach and hits targets at ranges of up to 400 kilometers, plus a microwave weapon mode at the radar. Each FX jet will be capable of flying up to 3 drones, which can be equipped with either reconnaissance equipment or missiles. The drones will improve the FX's offensive capabilities, while significantly reducing the vulnerability of the manned aircraft to enemy attacks. The aircraft will also possibly incorporate a high-speed data transmission technology called Integrated Fire Control for Fighters, IFCF, which could allow Japanese and possibly US fighters to combine their sensors, improving the accuracy of missiles beyond the line of sight. In developing such an ambitious project, Japan will be supported technically by Lockheed Martin in airframe design and system integration. The first will almost certainly include advice on radio absorption materials, as well as other techniques used by the firm to reduce the radar cross-section of its F-22 and F-35 fighters. Japan also hopes to pick Northrop Grumman's brains, especially regarding sensor and network warfare technology, which is widely used in the Grumman Super Hornet, the E-2D Advanced Hawkeye long-range radar detection and control aircraft, and the F-35 multi-sensor distributed aperture system. Tokyo has also stated a desire for input from the British company BAE Systems on the design, especially to interfere with electronic warfare and self-defense assets. BAE is the developer of the AN/ASQ-239 electronic warfare system for the F-35 Lightning. Japan plans to build the first FX prototype in 2024. The first flight will take place in 2028 and begin operation in 2035. As we can see, Tokyo proposed its vision of the 6th generation combat aircraft. Despite the rapid development of artificial intelligence, the Japanese see such a machine controlled by humans, but working in conjunction with several unmanned drones. But such technology is already being developed by the Russians for their 5th generation fighter Su-57. They've already tested a heavy drone Su-70 Hunter for it, and are going to supply it to the troops from 2024. Guided thrust vectoring has already been successfully implemented in the American F-22, and the Russian Su-35 and Su-30. So how then will the Japanese 6th generation fighter be fundamentally different from the existing 5th generation machines? So far, judging by the available information, the stealth of the aircraft will be significantly increased due to the fuselage made entirely of carbon fiber and the use of controlled plasma. Another significant innovation is the appearance of microwave weapons for protection against missiles, and that's about it. Don't you think that this is not enough to consider it a next-generation airplane? What do you think? It would be interesting to know how the main players, the USA, China, and Russia, see the 6th-generation combat aircraft. Write your thoughts in the post below this video. If you liked it, give it your likes, and of course don't forget to subscribe to our channel. There will be much more interesting stuff.